Welcome to the Composition Challenge. In this challenge, you need to create an application for controlling a smart kitchen. Your smart kitchen will have several appliances. Your appliances will be Internet of Things, IoT devices, which can be programmed. For example, you might automate things in your kitchen in the morning, such as brewing coffee, because you are always in a rush to get to work. It's your job to write the code to enable your smart kitchen application to execute certain jobs. Methods on your Smart Kitchen class will determine what work needs to be done. Add water will set the coffee maker's has work to do field to true. Pour milk will also set the refrigerator's has work to do to true. And finally, load dishwasher will set the has work to do flag to true for that appliance. Alternately, you could have a single method called setKitchenState that takes 3 Boolean values, which would set each appliance accordingly. To execute the work needed to be done by the appliances, you'll implement this in 2 ways. First, your application will access each appliance by using a getter and execute a method. The appliance methods are order food on refrigerator, do dishes on dishwasher, and brew coffee on coffee maker. These methods should check the has work to do flag, and if true, print a message out indicating what work is being done. Second, your application won't access the appliances directly. It should call do kitchen work, which delegates the work to any of its appliances. Okay, go ahead and do that. Write code that represents the smart kitchen and see what you can come back with. You'll have to create the appliances as classes, each with their own methods, as I've shown you on the diagram, and then compose your smart kitchen with these appliances. When you're ready, come back and check out my solution. Pause the video now. Hopefully you managed to figure that out and you had some fun along the way. Let's go ahead and now implement one possible scenario. I've already created a new project called Composition Challenge and created the usual main class and main method. The first thing I'll do is create the Smart Kitchen class. I can expand the project panel, right-click on the SRC folder, New Java class and type in Smart Kitchen. And I'll add the attributes even though I haven't created the individual appliance classes yet. Private Coffee Maker Brewmaster, Private Refrigerator Icebox, Private Dishwasher Dishwasher. Okay, that's not going to compile until I create these classes, and I'm just going to add these classes in this same source file. After the last closing class bracket, I'll type in the code for the Coffee Maker class. I could have had all of my appliance inherit from a base class. Maybe you did that, and that would be one valid way to do this. For simplicity, I'm not going to include inheritance in my solution, and this means my appliances won't be extending any class other than the implied one, object. Okay, we know Coffee Maker needs one attribute, has work to do, a Boolean class Coffee Maker. Private Boolean has work to do. And I'll use IntelliJ's code generation tool to add the setter method for this Boolean flag. I'll now add the method I want to run if there's work to do. For the Coffee Maker appliance, this is the brew coffee method. First, I'll make sure there's work to do by checking the attribute. If it's true, I'll just print the text, brewing coffee, and set has work to do to false after, public void brew coffee. If, parentheses, has work to do, print brewing coffee, set has work to do to false. Okay, that's the Coffee Maker class. Now I'll just copy and paste that entire class, and I'll rename the copy to refrigerator, and I'll change its method name from brew coffee to order food in this case, and then I want to change the text in the println statement to a message appropriate for the refrigerator, and finally, for the last appliance, I'll paste the Coffee Maker class again. I'll rename it this time to dishwasher. I'll change the method name from brew coffee to do dishes. And I'll change the text being printed to washing dishes. Okay, now that I have my 3 appliances, I can get back to the Smart Kitchen class, which you can see no longer has compilation errors. Next, I want to add a constructor. When I create a new Smart Kitchen, I'm just going to instantiate my own set of appliances by creating my own noArguments constructor. This means that any code creating a Smart Kitchen won't have to create the appliances individually, like I did with the personal computer example in the previous video. In this case, I'm saying the kitchen comes with a standard set of appliances when it's created. I'll add the noArguments constructor. Brewmaster equals new Coffee Maker icebox equals new refrigerator, dishwasher equals new dishwasher. And now let's generate the getters. And that does it for the Smart Kitchen. Let's go back to the main class, main method. I'll create a new instance of a Smart Kitchen, and then I'll use the getter methods to call specific methods on the appliances I know are in the kitchen. Smart Kitchen kitchen equals new Smart Kitchen. Kitchen.getDishwasher, parentheses, .do dishes. Kitchen.getIcebox, parentheses, .orderfood. Kitchen.getBrewmaster, parentheses, .brewcoffee. Okay, that's the setup. If I run that though, I'm not going to get any output. That's because all the methods expect that the has work to do flag on the appliance to be set somehow. Before these appliances can be ready to do something, I want to put a dish in the dishwasher, use up some products in the fridge, or put water and coffee grounds in the coffee maker, for example. I'll use the getter methods on kitchen to emulate that work first to set some of these appliances into a state of readiness. Kitchen.getDishwasher, parentheses, .set has work to do, with true as the argument. Kitchen.getIcebox, parentheses, .set has work to do, and true again as the argument. Kitchen.getBrewmaster, parentheses, .set has work to do, true. Now I've set things up, and the appliances are aware of work to be done. Running this code. You can see that my smart appliances ran, they washed dishes, ordered food, and brewed the coffee. That was calling methods outside of the kitchen with code that is aware of the different appliances in the kitchen. I used the get methods to call methods on specific parts of the kitchen. Now let's create two more methods on Smart Kitchen that hide some of the details from the calling code. I'll just give the calling code a method to pass some Boolean flags to my kitchen, and if the kitchen has a smart appliance that cares about that flag, I'll set that flag. Public void set kitchen state with three parameters: Boolean coffee flag, Boolean fridge flag, and Boolean dishwasher flag. Brewmaster.set has work to do, passing coffee flag. Icebox.set has work to do, passing fridge flag. And dishwasher.set has work to do, passing dishwasher flag. Okay, here I have a single method that can set each of the appliances has work to do Boolean flags property. Let's create a method on Smart Kitchen called doKitchenWork. This method hides what work will be done from the calling code, which doesn't really care about all the individual work items. And I want to add this method, which calls each appliances method that does the work. Public void doKitchenWork. Brewmaster.brewcoffee, icebox.orderfood, dishwasher.dodishes. Okay, now going back to the main method, I'll comment out the code that sets the state and called each appliance's work method. Instead, I'll call the one method on kitchen to set our appliance's readiness state. This time, I'll just set work to be done on the coffee maker and dishwasher. Lastly, I'll call the doKitchenWork method, kitchen.setKitchenState, passing true, false, true, and I'll call kitchen.doKitchenWork. And if I run that code, because I only said there was work for the coffee maker and dishwasher, we see that only those two appliances do their bit of work. You can see the output, brewing coffee and washing dishes. If our Smart Kitchen added or removed appliances, or their types changed, the method doKitchenWork could still be called the same way from the calling code. This means that Smart Kitchen can manage all its appliances and their inner workings, simplifying what the calling code needs to know and do. Hopefully you can see that composition is very, very powerful. As we progress through this course, you'll see examples of composition, and as I mentioned earlier, you'll understand more where to use inheritance and where to use composition. Generally, a lot of object-oriented programming experts suggest you try to aim to use composition over inheritance, or to at least look at composition first. Hopefully you did well on your challenge. In the next video, I'm going to talk more about encapsulation, which is another component of object-oriented programming. I'm going to explain that in more detail in the next video, so let's move on.